Okay everybody, so I just finished this here a few minutes ago. Now it may not look like much, it looks just pretty much a standard class file that you would see in a Minecraft mod that does inventory code, etc, etc. But what is not apparent with this is that this is not a handwritten file. I didn't write this, I didn't make it. It is a generated class file with a system I just created. The system is going to be part of a larger bit of code that I've been designing and working on for the past year. So I've went on designed it. I've written a few documents describing how this whole system would work here several months ago, and kind of have been envisioning this as a system for years. One of the first ways I kind of looked at it is trying to do this with ASM, do this with injection and stuff like that. But what I ended up figuring out here a couple months ago is that the most ideal solution is to write code that writes code. It may sound weird is to create code that can write code, and people will be going, oh no, you're going to make AIs that write code. It's not good. Don't worry about that. This is pretty simplistic. It works in a very similar way to JavaScript's tag injection system, where you could tell an HTML file you want to add more to it. PHP does something similar with its imports and everything else. So it's not overly complicated, but it will be built on over time to make it a much more intelligent system that understands what it's doing. For the moment, it takes in a template. You tell it via annotations what to do to create this file. Now when you look at this file, it will tell you that it's imported some fields and that it has imported some methods. Here's all the methods. It has taken in some interfaces and extend all the imports and everything else. Now I haven't really tested this file, by the way, so I'm not sure if it compiles as the moment, but I know the code generation works, and I'll go through the system here. Now this is the template it actually is pulling from. If you look at this, this looks pretty similar to here. The key difference is that there's a constructor here, which is about the only major difference between these two files. But this template is broken down into pieces, and it is merged with multiple templates. So if I had more than one template being defined, it would actually inject more templates. Now that's not to say it would inject all the templates that are present, because after all, it is annotation driven, so you have to put an annotation at the top of your class to tell it how to work. Now let me go find one of the test templates we're working with, or test files we're working with. So this is the logic class. This is designed using my node system, which was inspired by Calclavia. Calclavia came up with this idea originally back when I was working with him. I had a similar idea before he made his as well. We kind of ended up collaborating and actually making the node system, which was part of universal electricity for a while, was how we were envisioning UE 4 and 5 doing power, is in which instead of creating logic class inside instead of creating logic inside your tile to define how power worked, you created a node. The node went, hey, I need power, I need voltage, I need ampage, and then you pass that into your power grid, and your power grid okays, I got a new node connection and everything, and then it does all the work for you, and you didn't have to do anything. I am going to still implement that system, by the way, but this has nothing to do with it. The only reason I noted is that these both use a node-based system, and how the node works is that you have a block. The block defines a tile entity, and the tile entity you define a node. So if we look at this is a node. It extends a prefab, which extends iTileNode. iTileNode has a host. It is hosted inside of a tile entity wrapper. This is what the processor is doing. It is creating a tile entity wrapper. So if I actually go here, what it is doing is it's creating something that extends this. This contains basic update code, cleanup code, and validate, saving, description package, just your basics. But all of the logic is controlled by the node, which is really important because it takes away the need to build the tile entity class, and it takes away the need to build the block class. Here later, all of the block data is going to be defined by JSON, so what you'll do is create a JSON file that'll go, okay, I want a block who has a strength of such and such and has a name of this. Then it needs to define as its metadata 0 the logic tile of this. And via that logic tile, it'll create the wrapper, and the wrapper will instantiate the tile. So we got right here tile test, which by the way, this code wouldn't compile because it's actually missing this, but I got more work to do on this. I just finished this today. It's pretty good considering the fact I started working on it about yesterday at 10 o'clock and have been on and off working on it till about 5-6 here. I did take a break, but we'll go over more details of it here. So it's broken into two main parts. You have the processors, which are actually the templates. The processors will load up the templates and figure out what they're doing. Then you have the actual parser, which parses our logic tile class here. and actually figures out that, hey, we need to make a wrapper for this class. It needs to be registered with the ID code gen test tile. So this will be what Forge recognizes as the tile. And here's the class name file. And then it also says, okay, this also needs to be wrapped with inventory. If we don't put the inventory wrapper here, so say if I remove this real quick and I hit run, this class will reload. And there's nothing in here because it'll go, hey, well, we're pulling in fields from empty, there's nothing in the empty file, and we're going to pull methods from empty, and there's nothing in the empty file. This is empty right here. It's just got some documentation to tell people how to make templates. Right now, because I haven't written this sophisticated code yet to do this, you have to define where your fields are in the file, and you have to define where your methods are. If I open this up, you'll see that there's a start here, and there's an end all the way at the bottom. This is just to make the parsing easier. It doesn't have to actually be done this way, but I didn't want to write really strong code that would figure out, okay, this is a method, this method has this annotation and everything else, because that would take a lot of work, and this is the simple method to get me going. It's the main goal for the next week or so is to get VoltsEngine set up for its new iteration. It's finally getting pushed to release 1, so it's actually going to be into, well, actually we're going to call it beta 1 because it was in alpha. We finally figured out where we're going with it, so it's going to be introduced into beta here pretty soon. We'll probably never hit a release cycle, but the goal is I got to restructure it. It's been broken down into a ton of little pieces here. Let me go ahead and find this. So I actually did transition all the code over to its own organization now. It's called the VoltsEngine project. We'll probably make an area on the site explaining what this is, and it'll be treated as kind of a sub-organization as part of BuiltBrokenModding, but there's an engine API. Here's the actual build system which will run. We are working on a new one. This is the old one, which will make a single jar file. The new one will make subjars, but then we'll make a jar.all. The jar.all is what people will install. The subjars will be used for development only. Here's our fluid thing. There's a lot of stuff in here. Like I'm actually sitting and breaking apart all the VoltsEngines, but back to the processor since that's the main thing. So if we go back here, so we load in some arguments, we figure out where our folders are, we load up the processors, and then we load up the actual class files. When it actually loads a processor, it'll actually initialize load class, and we spend a lot of time parsing it here. We find the imports, we figure out what classes, we figure out what the header is, because this is where the header is found, these are where the imports found. Once we figure out where our header is, we then grab the annotations. From here, we then figure out where the imports are at, and there's tons of stuff in here. Methods and fields are in here as well, which are at the bottom here. Everything's done with regex at the moment, which is a big mess by itself. Here's where I was talking about the reason why we have a start and end, because it's really easy to parse this out with regex. I will figure out how to regex a field and regex a method here. I have already figured out how to regex comments, which is right here, multi-line comment is regexed. These are removed in case somebody decides to be pretty much a jackass, because I won't be nice about this. So let me go find this. Like if somebody decides right here to be a jackass and go and put a comment right there for whatever reason, it will remove that, because that shouldn't be there to start with, and it will bitch at you when you actually try to do that, because Java standard says you can't put anything in here. It won't error out, but you're not supposed to have stuff in here. It also doesn't care if you do stuff like this. It will parse this properly. It'll parse this properly if you screw up and do kind of stuff like that. It doesn't really matter. I have designed it to kind of get around some of this. I do prefer if it is all one line because it will parse faster. Same with these right here. They'll parse faster if each annotation is on a separate line. It doesn't care about comments here. It does not really check with the packages here. So if you make a package here with that says template and this is where it is, this is going to be ignored. What it actually uses for its package will be the package of the test class. This will be modifiable here later via the annotation here, but right now it's going to output into the same directory as your test tile. This is just to simplify things. Outside that, that's pretty much it for the processor. It is really super simple. It is based on the same technology that we're using for the Wiki Builder. The Wiki Builder is a template-based system. This will end up using some of the same stuff the Wiki Builder will use. So we'll end up having injection keys, we'll end up having data dependencies. There will be so much stuff you can do with the injection system in order to make classes better. And one of the whole reasons we're doing this, of course, is that I want to be able to make a logic class, kind of how GregTech does this, and a few other mods do this. Just to keep a note, I'm not copying off them, but they do this type of system, but they have issues with it because they have to create their logic object inside of their tile. And when they do this, you'll see some block render right when you log in, then it'll switch to the render-based system. I want to make sure that doesn't happen, and I want to make sure that when a tile is created, it is locked in with that logic class. And as well, I don't want to run into issues where I'm wrappering a tile with everything, because if we go and look at, well, let me restore the tile templates system here. So if we restore this and hit run, it should rebuild. Well, that is dependent on if Notepad decides it wants to remember that I have changed files. Okay, so if you look at this, we have our inventory code here. We know we are an inventory provider, we know we're an I provider. If I didn't do a system like this where we're wrapping and we're picking our interfaces, I would end up creating a class which is very similar. I already have one, which is tile machine, or tile modular machine inside Voltage right now is a clusterfuck of multiple classes. It has inventory code on it, has energy code on it, has frequency code on it, it has GUI code on it, has interaction code on it, permission code on it. It has so many different pieces on it just because everything that depends on it needs something else, but not everything that extends it needs all the parts. This is where the wrapper system comes in play. If I want inventory code only, I apply inventory code only. If I want fluid tank code on here, I can add fluid tank code. If I want energy code on here, I add energy code. And I don't have to sit here and make this huge class to just get a few different things. Now, people who are familiar with coding know that there are ways around this. I could create multiple different dependencies or multiple different prefabs that I can add dependency on to do different things. That's a whole other monster of itself, and you end up with a lot of a mess to do that. The other alternative is you end up using Scala, so you can have multi-inheritance. If you're really good with interfaces in Java 8, you can also do multi-inheritance that way, but it's a lot more messier. It's actually one of the issues I'm going to have to deal with this is because this is technically a multi-inheritance system where I can extend multiple classes at the same time. So there's all kinds of stuff with that. So one of the reasons I actually need to end up parsing methods is if I need to get the method name. If you have two methods that overlap each other, it has to error out and say, hey, you got to fix this on your own. In theory, you should never have overlapping methods, especially in the case if you need to save code or you need to save data in your tile. So the conventional way to save data in your tile is to call write to MBT and read from MBT. You should never have that in your template. You should never be saving anything inside the wrapper. Everything should be saved inside of your tile node. So that problem solves itself. There are some other problems though that might come into play, like if you have multiple get inventory calls. The rest of the inventory code should never be an issue because you shouldn't be calling quite a bit of this. Quite a bit of this should be pretty standardized. And most of this is wrappered anyways. A lot of this code was actually copied from my inventory wrapper, which I already have, which is designed to work with my iInventory provider. The iInventory provider is a system that's designed so that way you pretty much call get inventory, and get inventory is an object stored somewhere that tells you what your inventory is. In this case, we look at if we can go find tile test node, wherever it went to. We actually have inventory here. We create a new inventory, we pass the inventory back, and this course is being accessed via iInventory provider, which is then being accessed here in return, and all the other get inventory code works. So that means people can have access to all of my inventory stuff without me implementing a single bit of inventory code in this actual class other than the get inventory. And that's pretty much it on that one, but it's an amazing concept to think about. Well, at least I think it's amazing, but most of you guys won't. To be honest, most of this probably sounds like rambling because I've had almost no sleep. But yeah, probably gonna make some more videos here later showing this off. Actually, probably make a video here after this showing how to make a template because that's gonna be kind of important. But I'm gonna stop this video now and go take a break so I don't sound like I'm continuously rambling.